Inshallah, in this class, today's class, inshallah, we are going to see the consistency and inconsistency of non-homogeneous linear equations. Now on the board, I have written one example for non-homogeneous linear equations of variables 3. You see here we are having three variables x, y, z, three variables. Sometimes the question will be given in four variables. Okay, mostly the questions will be either in three variables or two variables. You see here, if we are having all these three zeros, here also zero, here also zero, here also zero, then we call this homogeneous equation. If we have numbers other than zero, even one also, suppose here we are having some constants, then we call this non-homogeneous linear equations. Non-homogeneous linear equations. Now to find the values of x and y and z, we have some procedures. We see it later. Okay, first you understand what is this augmented matrix. Okay, in augmented matrix we write all the coefficients of x, y, z with constants a1, b1, c1, d1, a2, b2, c2, d2, like this. Okay, in short I am explaining this. Okay, now there is a constant of this. What is the concept you see here? If the rank of A equals to rank of D equals to n. N means number of variables. In the above we are having three variables, that is n equals to 3. Suppose if the variables are given 4, then n equals to 4. So n means number of variables. So if rank of A equals to rank of AD equals to n, we say the system of equations are consistent and unique solution. The system of equations are consistent and unique solution. If suppose they both have the same rank of A equals to rank of AD, but it is less than n, but it is less than n. For instance, both rank is 2, whereas the variables are 3, or both ranks are 2 and the variable is 4, then we say consistent but infinite solution. Consistent but infinite solution. In infinite solution, we will not get all the values of x, y, z or w variables. For that, we have to take one or two arbitrary constants. We'll see in the question. Just you understand this formula. Number of arbitrary constants will be n minus r. We will see this in later in the questions. When we solve the questions, I'll explain this one. Okay, lastly, if the rank of A is not equals to rank of AD, then we say that the system of equations are inconsistent. Inconsistent means they do not have any solutions. Consistent unique solution means value of x is 1, value of 1, x, y, z will have only one solutions. Infinite solutions means we will get many solutions for x, y, z. Whereas no solution is inconsistent means no solution. Now let me see how do we take the rank of the matrix. You see in the on the board, I have just taken one example. Suppose the question is given like this. So how many variables are there? 4 variables, x1, x2, x3, x4. 4 variables, and the equations are given 4 only. So first we take coefficients 3, 4, minus 1, 1, 5, minus 1, 2, 1, minus 4, 1, like that. So we write this as augmented matrix AD. There are many methods to write the augmented matrix. I am using one. See here. Now watch carefully. The first, second, third, fourth. This rows, actually this belongs to matrix A. Matrix A. And this is the constant matrix D. This is the constant matrix D. To find the rank, let me change into echelon form. We already learned how to make the echelon form. Okay. In the first step, we make this 2 zeros. In the second step, we make this 2 zeros. In the third step, we make this 0. For to make these 3 zeros, we use R1. To make this 2 zeros, we use R2. This to make this 0, we use R3. For example, suppose we have changed like this. Okay, just this is an example, not the actual question. Now see here how to find the rank. Just you put a line here. Okay, this means rank of A. This means rank of A. Got it? Suppose here the number is left. How many rows are there? 1, 2, 3, 4. So rank of A will be 4. Rank of A will be 4. Suppose we got here 0, then the rank of A will be 3, because this all zeros, we do not count this row. Suppose we are having here also 0, so the rank of A will be 2. Got it? Suppose we are having number here, here, and also some number here. Now watch here. Now when we take this row also together, then we call AD. We take only this much, we call A. We say this is matrix A. When we take the complete, we say AD. Okay. Now the rank of A is 4, rank of AD is also 4. But suppose here it is 0, then the rank of A will be 4. The rank of A will be, sorry, 3. The rank of A will be 3. But rank of AD means, it is number is left here. AD means all the complete row from here to here. Here is number is left, not 0. So its rank is 4. Rank of A is 3. Rank of A is 4. Just I am explaining how to change. Okay. Suppose we are having here also 0. Then what we say? The rank of A is 3. The rank of AD also 3. Suppose we are having number here too. Now what is the rank of A? 4. The rank of AD will also be 4. Don't confuse, okay? Because it is 0 here, we should not think that its rank of AD is 3, because here is the number. This number, because here is the number. The rank of AD means all the columns. So the rank of AD is also 4. Rank of A is also 4. Suppose we are having 0 here and zeros here. Now what is the rank of A? The rank of A will be 2. The rank, because this we cannot count. Whereas the rank of AD will be 3, because here is the number. Rank of AD will be 3. Whereas the rank of A will be 2. So you just revise this, see this. Okay, this is the main concept. You remember this. Let me do one question based on these questions. Based on this concept, let me do one question. Now see here one example is written on the board. Solve. Okay. What, let me write the coefficients augmented matrix. I have taken 1 1 1 4, 2 5 minus 2 3, 1 7 minus 7 5. So this is actually 3 by 4 matrix. No, this, let me make two zeros here. In the first step, make this 0 and this 0 equivalent form. In the next step, let me make this 0. When we make these three zeros, we can say the rank. This two zeros in the first step and this next in the next step. So let me make this 0. This is R2. R2 implies this is 2, no? So multiply this one with 2. 2 minus 2 will become 0. 2 minus 2 will become 0. Therefore R2 implies R2 minus 2 R1. Now R3 implies this is 1. This is 1. 1 minus 1 will be 0. So R3 implies R3 minus R1. So let me change this. I'm writing here equivalent to, we are not changing R1, right, as it is 1 1 1 4. So R2 minus 2 R1 minus 2 ones are 2, 2 minus 2 0. R2 minus 2 R1, 2 ones are 2, 5 minus 2 3. R2 minus 2 R1, 2 ones are 2, minus 2 minus 2 minus 4. R2 minus 2 R1, 2 fours are 8, 3 minus 8 minus 5. Now let me go here. Now this is very easy. R3 minus R1, 1 minus 1 0, 7 minus 1 6, minus 1 minus 1 minus 7 minus 1 minus 8, 5 minus 4 1. So we got the first step. We got the first step. Now next step is here. In the second step, we have to make this one 0. So this is R3. Therefore R3 implies R3. Watch here. To make this 0, we use R2. We use R2. So if you multiply this with 2, this will be 2 3s of 6. 6 minus 6 will be 0. 6 minus 6 will be 0. So write R3 implies R3 minus 2 R2. 2 3s are 6. 6 minus 6 will become 0. So I am writing like this. Watch here. We are not changing the first row as it is. We are not changing the second row as it is. Now we are changing third row. R3 minus 2R. Both are 0. So 0 into any number 0. R3 minus 2R. 2 or 3s are 6. 6 minus 6 0. Now watch here carefully. Minus 8 minus into minus plus 2 4s are 8. Plus 8 minus 8 0. Okay, then lastly R3 minus into minus plus 2 5s are 10, 10 plus 1 11. Now we have changed this 2 zeros, this 0 into echelon form. Now after echelon changing into echelon form, you do one thing, you put a line here. Okay, now this will be the rank of A. This will be the rank of A. Because we got 0 here, this row we will not count. because this is 0, all these 3 zeros. So the rank of A will be 2. The rank of A will be 2. Rank of A equals to 2. Whereas you see here, if we take AD means complete. Here the number is left. So the rank of AD will be 3. The rank of AD will be 3. The rank of AD will be 3. Since two ranks are not equal, therefore we write rank of A is not equals to rank of AD. So this is the last condition. When two ranks are not equal, we say the system of equations are inconsistent. The system of equations are inconsistent. What is the meaning of inconsistent? That means they do not have any solution. So we write they have therefore no solution. In short, I am writing no solution. The system, you write like this: the system of linear equations are inconsistent and hence have no solution. And hence have no solution. So let me do one more question. See, one more question is there on the board. Now I have written the augmented matrix 2 minus 1 3 9 1 1 1 6 1 minus 1. See here, first step we have to make this two zeros using R1. But if we have, in place of 2, if we change this to 1, it will be easier to make zeros. Let me change here. We bring the R2 here. We will bring 1 here, okay? So we can change like this. R1 by implies R2. Let me bring this here, okay? So what is left here? How we'll do? We are interchanging the two rows R1, R2. So R1 we can write here 1 1 1 6. R2 here 2 minus 1 3 9, and then lastly 1 minus 1 1 2. Now let me change this 2 into zeros and transfer this one to 0. So R2 implies R2 minus 2 R1. 2 ones are 2. 2 minus 2 0. R2 minus 2 R1. R2 minus 2 R1. The same way R3 minus R1. R3 implies R3 minus R1. Now changing here. See here. First row we are not changing. Let me write as it is 1 1 1 6. R2 minus 2 R1. 2 ones are 2. 2 minus 2 0. R2 minus 2 R1. Minus 2 ones are 2. Minus 1 minus 2 minus 3. R2 minus 2 R1. So minus 1 minus 2 ones are 2 minus 3. 3 minus 2 is 2. 3 minus 2 is 1. 9 minus 6 2 is 12. 9 minus 12 is minus 3. Now lastly R3 minus R1. 1 minus 1 0. Minus 1 minus 1 minus 2. 1 minus 1 0. 2 minus 6 minus 4. 2 minus 6 minus 4. Now we made already this one 2 zeros. Now we have to make this one 0. Okay, so I'm changing like this. R3 implies, you see here, we have to make these two numbers same. So multiply this with 3. 3 2s are 6. This 2 2 3s are 6. 6 minus 6 will become 0. So R3 implies, for R3 we multiply with 3. 3 R3 minus, we have to multiply this with 2. Minus 2 R2. Okay, now let me change here itself. 1 1 1 6. We are not changing the second one. 0 minus 3 1 minus 3. Now lastly we are changing here. 0 will remain 0. Both are 0. Now if you multiply with this 3, 3 2 are 6 minus 6 minus 1 is plus 6 will be 0. 3 R3 minus 2 R2. 3 R3 means 3 into 0 into 3 into 0 0 minus 2 R2 minus 2 ones are 2. Now lastly here 3 into minus 4 will be minus 12. 3 into minus 4 will be minus 12. 3 R3 minus 2 R2 minus 2 minus plus 2 3s are 6. Minus 12 plus 6 will be minus 6. Minus 12 plus 6 will be minus 6. So we got here. Now let me see the first ranks. What are the ranks? I just explained. No, you do one thing. You put a line here. Now this is A. The complete matrix is AD. This is A. And the complete matrix is AD. So rank of A will be 3. Rank of A equals to 3. What is the rank of AD? Rank of AD is also 3 because we are having numbers here. And how many variables are there? N means number of variables. We are having 3 variables, x, y, z. So 3. Now what is the condition here? The first condition. Therefore, rank of A equals to rank of AD equals to 3. Therefore, the system of equations are consistent. What we write? Consistent and have unique solution. And have unique solution. Now, how to find the solution? You see here, in the last step before making 0, again you do one thing. You keep here x, y, z, x, y, z, x, y, z. 1x means x. So it will be x plus 1y will be y plus 1z means z equals to 6. One equation got. Here x, 0x means 0, leave this one, minus 3y minus 3y plus 1z means z equals to minus 3. X plus y plus z equals to 6. X is 0, minus 3y plus z equals to minus 3. X is 0, y is 0, minus 2z equals to minus 6. So we got again 3 equations. Now see here, watch carefully. From this we will get z. If you substitute here z, you will get y. If you substitute y and z here, you will get x. So minus minus will get cancelled. 2 1s are 2 3s are. So you got z equals to 3. Now put z here, minus 3y plus 3 equals to minus 3. Bring this minus 3 here, minus 3 minus 3 minus 6. Minus 3y equals to minus 6. Minus minus cancel. 3 1s are 3 2s are. So y equals to 2. So we got y and z. Let me substitute this here. X plus y is 2 plus z is 3 equals to 6. 3 plus 2 5. Bring this 5 here, minus 5. 6 minus 5 is 1. Therefore solution is x equals to 1, y equals to 2 and z equals to 3 is the required solution. Test the consistency of non-homogeneous equations. If consistent, find the solution. Now in this question we have 4 variables, see, x, y, z and w. Let me write the augmented matrix. See here, x is 2, 3 minus 2. Here we don't have z, so write 0. W coefficient is minus 1 equals to 2. Here we don't have x, so write 0. Y 2 2 1 1. 1 minus 2 minus 3 2 3. Here also we don't have x, so write 0. So let me start now. In the first step we have to make a 0, this 3 zeros. Okay, we are already having 2 zeros. Let me make this one 0. Okay, so I'm just changing this one. R3 implies, see here, if you multiply with this with 3, it will be 3 ones are 3. 3 minus 3 will become 0. So multiply 3 into R3. 3 into R3 minus R1. 3 into R3 minus R1. So let me continue here. See here, equivalent to, now we are changing only third row, right? The other rows as it is, minus 3, 3 minus 3, 0, minus 1, 2, 0, 2, 2, 1, 1. Now see here, 3R3 minus R1. 3 ones are 3. 3 minus 3 will become 0. 3R3. 3 into minus 2, minus 6. Minus 1 is plus 2. Minus 6 plus 2 will be minus 4. And here also 3R3. 3 3s are 9. Minus 9 minus 0 will be minus 9. 3R3. 3 2s are 6. Minus 1 is plus 1. 6 plus 1 7. 3 3s are 9. 9 minus 2 will be 7. 9 minus 2 will be 7. You see once more, 3 1s are 3. 3 minus 3 is 0. 3 2s are 6. Minus 6 minus 1 is plus 2 will be minus 4. Minus 9. 3 2s are 6. Minus of minus plus 1 7. 3 2s are 6. Here 3 2s are 6. So 3 3s are 9. 9 minus 2 will be 7. The fourth row as it is 0 1 2 1 1. Now first step we made these 3 zeros. Now next step we have to make this 2 zeros. Okay, we can shift 1 also here. Without doing also we can change. Let me change this one, R2. So we write R2 implies, you multiply this with 2, sorry, R3, no, R3 implies, this is minus 4. If you multiply with plus 2, this will be plus 4. Minus 4 plus 4, 0. R3 plus 2R2. R3 implies R3 plus 2R2. Now R4 implies, This is 1, so multiply this with 2. 2 ones are 2. 2 minus 2 will become 0. 2r4 minus r2. 2r4 minus r2. So let me change. We are not changing the first row and second row, so right is it as it is. First row we have 3 minus 2 0 minus 1 2. Second row also we are not changing, 2 0 2 2 1 1. The third row r3 plus 2 r2, r3 plus 2 r2, 0 0 remains 0. 2 1 2 is 4 minus 4 0. 2 2 is 4, 4 minus 9 minus 5. 2 1 is 2. 2 plus 2 plus 7 will be 9. 2 1s 2. 2 plus 7 will be 9. So the next step, 2r4 minus r3. 2r4 minus r2. This remains 0. 2 1s are 2. 2 minus 2 0. 2 2s are 4. 4 minus 2 will be 2. 2 2s are 4. 4 minus 2 will be 2. The last one, 2 1s are 2. 2 minus 1 will be 1. 2 1s are 2. 2 minus 1 1. This is also 2 1s are 2. 2 minus 1 1. Now what is left here? This 3 zeros, this 2 zeros, and lastly we must make this one 0. So to make this 0 we have to use R3. What is the procedure? Making this 3 zeros we use R1. Making this 2 zeros we use R2. To make this 0 use R3. So let me do this one. What is the procedure? R4. This is therefore R4 implies. So multiply this with 5. 5 2s are 10. 5 2s are 10. So multiply this R4 with 5 and R3 with 2. R4 implies 5 R4. Multiply this with 5. Multiply with 2. Already minus no, right, plus 2 R3. So I'm writing here itself. So we are not changing the first row. 3 minus 2 0 minus 1 2. We are not changing the second and third rows. 2 2 1 1. So this is 0 minus 5 9 9. So last one, 5 r4 plus r3, both are 0, so there will be no effect, both are 0. If you multiply this with 5 10 minus 2 5s are 10 minus 10 is 0. See, if you multiply this with 5, 5 ones are 5, 5 ones are 5, plus if you multiply this with 2 18. See once more, 5 r4, 5 ones are 5, plus 2 r3, 2 9s are 18. So 5 plus 18 will be 23. Same terms now, 23. So let me see the equations are consistent or not. Now we are having this, what's here, this one. This remains A. This matrix is A. This matrix is A. See here, we are left with one number here. So 1 2 3 4. The rank of A is 4. The rank of A is 4. Rank of AD, it's also 4 because we are having the numbers here. The rank of AD is 4. The variables also we are having 4, x y z w. So this is the first condition. Therefore rank of A equals to rank of AD equals to 4. The system of equations are consistent. The system of equations are consistent and have unique solution. Unique solution and have unique solution. Now let me find out the unique solution. Again, you substitute the values of x y z w. So what we left with, if you write x here, it will be 3x. If you write y here, minus 2y. 0 z, leave this one, minus w equals to 2. One equation we got here. So this x is 0. 2y plus 2z plus w equals to 1. Plus w equals to 1. Now see here, x is 0, y is 0, this is z. Minus 5z plus 9 equals 9w. 9w equals to 9. Now the lastly, what is here? 23z. 23z. 23z equals to 23. 23z equals to 23. 23 ones are 23 ones are. So we got z equals to 1. Z equals to 1. Sorry, here we have the w. This is w, no? x is 0, y is 0, z is 0. So 23w equals to 23. So we got w equals to 1. So let me put here w equals to 1. So 9 ones are 9. So 9 minus 5z plus 9 equals to 9. 9 minus 9 0. So minus 5z equals to 0, means z equals to 0. Now we got z also and w. Let me substitute here. 2y plus 2 into z is 0 plus w is 1 equals to 1. So this is 0. 1 minus 1 0. 2y equals to 0 means y equals to 0. So we got y also. Now let me substitute here. 3x minus 2 into 0 minus w is 1 equals to 2. Bring this one here, it will be 3. 3x equals to 3. Therefore x equals to 1. Therefore x equals to 1. Therefore we got the solution: x equals to 1, y equals to 0, z equals to 0, and w equals to 1. So let me finish this part today, inshallah. We are going to continue in the next part. So I request to subscribe this channel, like this channel, and share this with videos with your friends. Inshallah, we will continue in the next video. Inshallah, we will see how the questions can be solved if we get the answers as inconsistent solutions. We do the questions on inconsistent solutions and infinite solutions, inshallah, in the next class.